In this problem, you have to use the adjacency matrix for P8. This is the path on 8 vertices that we learned about in the Graph Theory 1 worksheet. And I have to be specific about exactly what the vertices are and what the edges are for us all to get, for there to be one correct right answer. And I'll show you why that is in just a moment. All right, so the first thing is P8. P8 is the path graph on 8 vertices. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 vertices, and it looks like this. So there's 8 vertices, 7 edges. All right, so the way that I've defined this here, let's pull the edges of P8 are, so vi plus 1, so starting at I and going to 7, that's what this says. So you have the edge v1, v2, v2, v3, v3, v4, and continuing on like that till you get to 7. So vi, that would be 7, and vi plus 1 would be 8. So you have v7, v8. Each of these is an edge. Remember, edges are 2-element subsets of the vertex set. All right, so because I've defined the edges in this way, the graph has to look like this. Here's v1, here's v2, here's v3, here's v4, here's v5, v6, v7, and v8. All right, so that's what the graph has to look like. Now it could look slightly different. It could start with v1 here and v2, v3, but notice that is exactly the same graph. If you think of when are two graphs the same, when you can pick one of them up off the page, rotate it around, and set it down on the other one. If you wrote this with v1 here, v2, and then on to v8 here, if you picked it up and turned it around, you could set it down on the other one. So it is the exact same graph. All right, so if I didn't say that this was the way that the edges were defined, then the adjacency matrix could actually be different. There's multiple adjacency matrices for the same graph that are determined by the way you label the vertices. So let's try and digest what that means here. All right, so the adjacency matrix for this, right, is going to be an 8 by 8. Now let's just look at a couple of let's say rows of the matrix. And let's say that we have exactly the same graph, but I've labeled the vertices different. Let's say that I labeled this V2, this V1, V3, V4, V5, V6, V7, V8. So it's exactly the same. It's exactly the same graph, but I've just labeled things differently. If you label things differently, you can get a different adjacency matrix. And so because I want because I want to be able to actually check this in a reasonable amount of time, I don't want to have to check every single possible different way that you could label these things, but have it be exactly the same graph, but have different adjacency matrices. Okay. All right. So so V1 is connected to V2 with an edge, right? So if you're looking at, say, this first row of the adjacency matrix, the way I have it, the way I have the edges defined here and the vertices defined here, then this is going to be, you have a 0, a 1, and then 8, 0. Let's see, 0, 1, so 1, 2, 3, 4, 5, 6, 7, 8. And then the next row, right, let's see, V2 is connected to V1. It's not connected to itself. It's connected to V3, and then the rest of these. And then, all right, so, and the rest of it, and just assume that I've filled in the rest of this adjacency matrix here. Now in red, let me do what the adjacency matrix would look like if I used this other labeling, where the labeling is almost exactly the same, except for I've just switched the positions of V2 and V1, of the labels V2 and V1. So I haven't really switched I haven't switched the positions of the vertices at all. That's why these are the same graphs, right? It's just a different labeling. If you label it different, you could get a different adjacency matrix. That's the point. Okay, so V1 now is, let's see, no, this doesn't work, does it? Let's see, using this labeling here, let's see, V1 is connected to V2, so let's see, V1 is not connected to itself, it's connected to 2 and 3 and nothing else. 1, 2, 3, 4, 5, 6, 7. Need another one over there. All right, and then V2 is connected to V1 and nothing else. And so here, notice that these two first rows are different, right? These two first rows here are different than these two first rows here. And so if I wasn't specific on how these things these things are labeled, what the vertices look like exactly, and what the edges are like exactly, what labels go on which things, then feasibly there would be more than one answer to each of these questions. But because of the way I've defined the edges here and the vertices here, there will be one and only one answer for each of these boxes, and then I can grade it. All right, so that's the long-winded explanation of why I've done this, and why I've done this complicated definition here of what the edges are. It's so that there is really only one answer. All right, so enough of that. Let's solve the problem. All right, so we're looking for what is A34. So A34 is a 1 if there's an edge between V3 and V4. And look, there is. There's an edge there. So this is a 1. What about 4, 7? Is there an edge from 4 to 7? No. There's a path, right? There's another path. There's a way to get from V4 to V7, but there's not a single edge. A single edge from V4 to V7 would be something like that. And there just isn't one of those. So this is a 0.